Okay, so on this one, let's try to solve a CTF challenge. This one is pretty simple. It's just having a file and you have to figure out, do some reverse engineering on it. And yeah, I thought it should be interesting because we are gonna get into assembly and that will help us in the long run because like we are building that compiler, so we have to get a bit used to seeing assembly more. So I mean, it's a good way to get used to assembly, to do some reverse engineering, in my opinion. So yeah, in this one we'll be using Radare to do reverse engineering on stuff. Um, have, I have used it a while back. I don't really remember all the commands. Hopefully I will be able to do stuff. And also GDB. And I really like this extension. It is really nice. It shows you all the registers, the stack, I think, also code in assembly, which, yeah, I mean, it's basically like Radare, but in GDB. And yeah, it's pretty nice to use this one. So I mean, um, this challenge, this room only requires you to download some files. So let's do that. And inside of here, I have a repo. And okay, so basically in this repo, I have a THM folder for try hacking. And inside of this, I have this makeroom.sh. And yeah, I have to give it the ID of the room, and it will create me a TMUX session for this one. So yeah, with the readme. I saw that a lot of people do readmes, but never really get to write them. So yeah, let's copy the executable. I mean, first let's see. So it's an executable. Uh, I mean, how many of us would have guessed? And yeah, dynamically linked, not stripped. I think not really sure what not stripped means because I don't think it refers to executable. I don't think it refers to symbols, right? When you compare with -g. Oh, it is, in fact, when you compare with -g. So yeah, usually if you compare something with -g, it's a really good idea, and at least for debugging purposes, right? So you can see, like, if you use any debugging tool, it will show you the line where you have an error. For example, if you have segmentation faults and you use Valgrind, or yeah, stuff like that. If you decompile code, it will show you the function names and stuff. That's pretty cool. So yeah, we have an executable. Let's try to run strings on it and see what we can find, if there's anything interesting. So yeah, we have some stuff, some random strings. It does some scanf, some string compares. I mean, I would expect to do some, I don't know, string compares and stuff. Strings th for noobs. Oh, okay. Try again. Correct. So it's like a password maybe. If it's password, then try again and stuff. So yeah, I mean, I guess we can try to run it. Hopefully it doesn't. But you know, I mean, it's never gonna be an issue with executables from there. So let's try to give it some random stuff. Try again. I would also just try to give it as much stuff as I can just to see if it crashes. I mean, if it doesn't crash with just that, I don't think it will crash at all. So, but it's still, let's do some printing in Python, and let's do like 100 characters, and let's pipe it into compiled. So yeah, it still doesn't crash. So as I said, I don't think it is a buffer overflow, because if we look, okay, let's go back on this one and see strings. So it's just reverse engineering binary, and you can look at the tags and see strings can only help you so far. I mean, I guess it was helpful because we realized that it's maybe password checking, and the password that we are gonna pass and get correct on it, it's gonna be the flag probably. So that's what we have to do. Okay, so let's try to open it in Radare, see what does. So as a small tutorial for Radare, we can do AAA, analyze the program, why not? Okay, and then let's see, AFL. So we have a main, that's good, and HGArt, ooh, PDF. I guess this is a okay, so PDF AGF, maybe combine both of them. Okay, that looks a bit better, but it's this refers to what, I guess. I mean, maybe we have to seek to main. Let's see what px30 does. We saw main there, so let's see if we do this thing, if it shows us the main. Okay, yeah, it does. So if we seek to main and then do this thing, it gives us some more stuff. Okay, so let's see what this thing tries to do. Right, so here is the main. Say it's int main argv. Okay, so basically here it moves some stuff. Strings is for noobs. Anyway, so then here you can see that it has a string password. Let's see what it does with it. So it's gonna call to write. Okay, so it's gonna call to write, and RDX is gonna be the first argument, I guess, as it says here. Size is 1 and items is A, which is 10, like the number of characters. So yeah, it's really nice. It shows us the function call and also the arguments. That's really cool. Then we have the format, and here it does a scanf. So with scanf, do you even %s CTF? Okay, so that means that, okay, so let's see what happens if you do scanf. So basically here when we read from the standard input, we have this format right here. Do you even %s CTF, right? So it means that you have to provide this thing, and only then you can put your string, right? So that's how scanf works. You have to actually, you cannot really just pass this and it will read it. You have to also put in, do even for some reason, right? So that's how like let's do a small main.c and see how it works. Main.c put stdio .h yeah, int main. Let's have a hello world, but instead scanf, and let's have a char str100, and let's say enter %s, and then we can put anything at the end, see what it happens, and then let's printf it. You enter. So now if we gcc main, okay, wait, I guess my Python brain took over its include. Yeah. Okay, so let's do main, and here if you put something, you don't get anything, but if you say enter and then text, you're gonna get a text. So that's the idea with that string there, right? We have to provide do you even and then our text. So then let's see what it does. It's gonna compare it with DSO handle. Pretty strange thing to compare it with, but it is what it is. Then we have a false and a true, right? So let's see what it does on the true first, because it's longer. Okay, it comes here, and on the false, it's gonna compare it with, again, what? Again with DSO handle? Am I editing this wrong? DSO handle. On false, it does it again. Interesting, it does it again. So it's gonna be like, let's say you pass in something other than DSO handle, it's gonna be false. Then it's gonna be false again. So it's gonna come on true. That's really strange. You know what it does? It's not if it's equal. I'm sorry, it's JS. Okay, so it's jump if it's if your text is smaller, right? JLE is basically jump if lower or equal than 0, I guess. Okay, let's see what assembly JS. I mean, it was like, oh, JavaScript. Assembly JavaScript. JS will jump if the sign flag is set. So like if it's negative, I said it right? So if it means that if our string is smaller than this one, I guess. If our string is smaller than this one, it will jump. Otherwise, it comes here. And then it's, again, if it's smaller, for some reason it does it twice. It jumps here. Okay. And it shows us try again, okay? And then we have another one. On this one, it compares with init. And if the string is basically, let's say, jump not equal. If it's not equal, it shows us try again. And if it's equal, it's going to show us correct. So I guess this comparison, right? is where you have to get, so init. So yeah, because S1 is basically where we put our stuff, right? Or is it? Yeah, I think it is, because here we put the what we got as the result from scanf. In S1, that's how it works, right? With scanf, I think. Yeah. Yeah, I mean, that's what would make sense to me, right? So you get correct, and then we automatically jump to exit. So I guess that's pretty much everything, but I'm not really sure how this DSO handle comparison really works. I mean, maybe we just have to provide init, but let's see. Let's try to also use GDB and do a break on main. See like some stuff what happens. So let's run it. I'll just make it a bit smaller just to see everything. Okay, so let's do next instruction a couple of times. Here we read. Here we do the scanf, right? So let's try to input something. Oh, my bad. It should be. I was like, why is it my program? GDB compile. So let's break main, run, and then next instruction. A couple of times here we get the right, so it's gonna show password. Right. And then let's keep going. Here we actually read the thing. So let's put in something. I mean, let's because we know that we have to provide do you even. Let's do that. Do you even, and let's put in test. See what happens with test. Okay, so we do a string compare between test and DSO handle. So let's see what happens. Jump is not taken. So if we go back to radar, it means that it comes to this false because it's not taken. Okay, let's see where it goes next. Jump is not taken. It does another string compare. And now it takes the jump, so it comes here. Okay. And that means it's gonna print, try again. And then it will actually leave. Okay, so if we provide the test string, it comes on the false and then on the true. Okay, so we have to figure out how we can get into this block then and have init. So let's try to make this jump. I mean, I don't know how to make this one jump, but I guess jump less equal. So my idea is how string compare works. Let's go ahead and make the font again larger. So let's do include string.h. And what's the string that we have? It's the SO handle. So let's have a string, a char pointer string equals to this stuff. And let's have something simple like percentage s just to be able to do something. Int cmp is str compare, and how do we compare it? We put DSO handle here, and our string we put it here. And let's see the compare. So we can gcc main and then run main. So if we provide DSO handle, it should say 1 sec. Yeah, pretty strange. Unhelpful as usual, ChatGPT. So DSO handle, it's equal, right? If we provide test as we did earlier, it's -11. What if we provide init? It's gonna be 10. What if we do something like a? I guess it should be smaller because d is smaller than a. I mean a is smaller than d, so it's gonna be -3. Okay. What if we do e? This should be 1, I think. Yeah, because it's the difference between e and 1. What if we do I? It's gonna be again 10. Yeah. So if we do anything like test, it's gonna be positive. Okay, so that means that if we go back here, I would like if be cool if you can have different zooms on each panel, but I guess it's more about Kitty. Anyway, let's run. Let's go next. And let's try to put in test now. Let's see what happens if we do lowercase, because lowercase is gonna be larger, so it might jump on the second one. So let's see. Here the jump is not taken, and here it should say jump is taken. Pretty interesting. Let me run again. So next instruction, not sure what happened there. So here we read, and I said even test. I forgot about the do you even. Next, so it does string compare. Jump is not taken. Yes, so the jump is not taken. It comes, yeah, maybe this one is in case you don't provide do you even, right? Like maybe that's the idea there. So let's see, it's not taken. So here we compare again with DSO handle, and I thought that the jump should be taken, jump less equal, right? Assembly. Jump if less than or equal. I mean, that's what I would have guessed that should happen there. Yeah, it's not taken, of course. So it's correct, right? It's not taken. So it should come here and compare with init, because test is larger than DSO handle. So then we string compare with init, and it doesn't equal, so it jumps. Okay, and it says try again. So I guess yeah, init is what's gonna work then. So if we do, I mean, let's just see. So compiled, and if we do you even init, Okay, so I guess we actually found it. So yeah, basically we saw that here it does some comparison, and basically this one just checks if you actually provided the prefix do you even. Then it compares if our string is larger than this thing. Well, I guess if it's smaller, and if it's smaller then it's gonna do fail, and if it's larger it's gonna compare with the actual thing which is in it. And yeah, if the value is not equal to init, then it's gonna fail, and if it's equal, it's gonna say correct. So I guess it looks a bit strange, but I mean I guess this is the flag. So let's see what happens if we put this in. Okay, so pretty nice. So yeah, we actually got the thing. So yeah, I mean to be honest, I didn't know it was easy meant this easy, to be fair, but yeah, I mean still I still like this kind of having to do assembly and reverse engineering stuff, so pretty nice. Yeah, so I mean the solution is just used radare 2 to see the assembly code. Well, I mean the disassembled code because it also has some really nice comments. You can also say that the binary is not stripped. Right, we saw that file compiled. So it was compiled with -g basically, and yeah, the password has the even prefix. First we check if the string is larger than DSO handle, and if it is, we compare with init, well, only one underline init, and if it is equal to init, it is correct. Yeah, so the password was do you even init, I guess. So yeah, I mean that was the password. So yeah, I guess that's then everything for this one, and yeah, I'll see you on the next one.